Welcome. In this video, we're going to learn the very basics of setting up an electric circuit using the Arduino here. You may or may not know that possibly more than 100 years ago, ships primarily communicated through flashing Morse code on lights. And lighthouses would be on the edge of a coast, especially where there were dangers for the ships, and they would flash messages as well. So in today's project, we're just going to create a super simple project here where we have the light on the ship or the lighthouse, and we have a button here, and when we hold the button down, the light turns on, and when we let go, the light turns off, which means that we could send Morse code signals. For this project, we'll be using an online environment called Tinkercad. If you Google Tinkercad, it is the first result here. Now you should be able to sign up or sign in with your Google account. Once you've done that, if you click on Create and Circuit, because Tinkercad also lets you do other things which we won't be doing, you will go to this view here. Now, just a brief introduction, we have this workspace on the left, and on the right hand side we have all of these electronic devices. We will be primarily using the Arduino, which is a small microcontroller chip on a computer board that can be used to write computer programs that control electronic devices. You can also drag on other things that you might need for your project, such as lights, resistors, and switches, etc. And you can, by left-clicking, wire up different components and connect them into electric circuits. You can also write code for the chip on the Arduino by clicking on the code button here. We will be using the text rather than the blocks, and the code will be written in a language called C++, which is fantastic for running very, very fast on low-powered, inexpensive chips like the Arduino. Your project should auto-save without you having to do anything. And if you want to change the name for what your saved file is, you can do so up here. Okay, let's get started on our Morse code light. So I'm going to click Create and go to a new circuit. Now the first thing that I'm going to need is the Arduino board, so I will drag that across. That is going to be the basis of our program. That will provide the power. In this case, for this project, we're actually not going to be doing any coding on the board, but we will be getting power out of its 5-volt connector here. The second thing we are going to need is a light bulb. So in the search here, if we search for light, here it is, it's coming up down here. We're just going to use a normal light bulb. And the one other element we will need is a button. So if we search for button, and we would like to get the push button here. So in case you don't know too much about electronics, if I take a wire by left-clicking from the 5 volts here, and I'll click it a few more times just to get some nice straight lines, and I connect it up to a light, and then I hit Start Simulation, power is provided to the Arduino. However, the light doesn't turn on. And the reason that it doesn't turn on is that with electronics, we need to have a complete circuit for the power to run through. Now, the way you can think about this is a little bit like a stream of water. If I had a pipe that was going somewhere, but the end of the pipe was blocked, I wouldn't be able to push water through that pipe. I would need the pipe to go out the other side and into some runoff area where it could flow through. And the runoff here we are going to put into the ground pins here. So if I take another wire and I go through here and I go to ground, don't be confused by these wires crossing over each other, that doesn't really make any difference. In fact, just to make it obvious, why don't we connect to the other ones? So we'll connect that one to ground and this one to the 5 volts. It does not matter which direction it's flowing through an incandescent light bulb, although it does with an LED, so we'll see that later. So now we've connected the light bulb from the 5 volts, and there is a circuit that then runs out to ground. So again, thinking if this was water, the water would be able to run through into the light bulb, through this filament here, which would provide some resistance, heating up and giving off heat and light, and then back down through here and back to ground. So let's click Start Simulation, and you can see that the light bulb has gone on. Now that's all very nice, but having a light that is permanently on is completely useless to us if we're trying to send Morse code. What we want is for when we press the button for the light to be on, and the moment we release it for the light to be off. So what this button is going to do is it's going to break and connect this circuit in order to turn the light on and off. So we know that when the circuit is connected, this light bulb will be on. But if there was a break in the circuit, it would turn the light bulb off. And that's what this button is going to do. If we connect the button up to either of the sides, but it doesn't matter because, again, if you think about it as a pipe of water, it doesn't matter where the blockage is or the disconnect is, it will stop water from flowing through the whole pipe. So I'm going to just put it this side for convenience. But if I connect one of the terminals on this side and one of the terminals on this side, now it looks like the circuit is connected. However, if we start the simulation, it is not, and when we press the button, it is. So what's going on? Let's have a little bit of a look at what's happening inside this button. So here's an outline of the button, and the button comes with a few little bits of metal which conduct electricity. So you'll notice that there are some pins sort of sticking out. Okay, so we have a pin here, and a pin here, and a pin here, and a pin here. So how do the electronics work inside? This pin is actually connected to this pin, and this pin is connected to this pin. So what this basically means is when you're connecting a wire to the button or putting the button in a circuit, if the circuit comes in from this direction, it can connect to either this pin or this pin on the bottom left. It doesn't matter. So you can connect to either that one. And when your wire is going out, it connects to either of those pins. It doesn't matter which one, and it can go out like this. That's fine. But when you put the button in the circuit, you'll notice that the light doesn't work anymore. And the reason that the light doesn't work anymore is that the circuit is broken inside the button like this. However, when you push the button, that brings this down to touch the other wire and completes the circuit. So the circuit is actually complete while the button is held down. So back in Tinkercad here, we can then imagine that the circuit comes in here. As I said, it doesn't matter whether you attach to 1A or 1B, they're just connected with wire. And we go out of terminal 2, and when we start the simulation, which means we plug in the Arduino here, you can see it being plugged in and has power. This circuit is broken in here. However, whenever we press the button, the light will go on. And that's it for our first project. We're just going over the basics and seeing how electric circuits work. Now there are a couple of things you could play around with to make this project a little bit more your own. Instead of powering it with an Arduino, perhaps you could see if you could power it with a 9-volt battery. Or perhaps instead of using this light bulb here, you could use an LED Now, LED stands for light emitting diode, and a diode is something that only allows electricity to pass through in one direction. So when you connect it up, one direction will work and one direction won't. And also, you might find something funny happens with the LED when we use it that might require you to try and put one of these in your circuit. But we'll talk about all of that in a future project. For the moment, have a bit of fun. Maybe you could even attach multiple light bulbs and see what happens. So have a play, and I'll see you in a future project.